In this unit, we are going to be discussing the graphs of polar coordinates and polar equations. We're going to keep them fairly simple, but we're going to learn a little bit about how a polar coordinate graph works and how to graph some simple equations, simple polar equations. So for today, we're just going to talk about how the polar graph and the rectangular graph, the normal coordinate grid graph, are compare to one another and how to graph polar coordinates. So let's start with how to graph polar coordinates. We're going to start at a fixed point. It's called the pole, and the pole is going to be like the origin of our graph. And they're going to give you some polar coordinate. R represents a radius and theta represents an angle. And so you'll go out some amount on your polar axis and then around whatever angle they give you, and that point will be your point P polar coordinate. So P is R theta, a radius and an angle. So this angle is either measured in degrees or radians for our coordinates. For most of the questions today, we're going to be given in degrees, but the graph is going to be in radians. So we need to know how to convert between the two. So here we go. It wants us to plot these points on the polar grid below. So our first point, point A, is 260. So we know 60 degrees is pi thirds radian measure. So we're going to go out positive 2. So from our pole, we're going out 1, 2, and then we're going around 60 degrees, or to pi thirds. So this would be point A. All right, point B is negative 260, also pi thirds, but negative 2 means from the pole we're going out to the left, negative 2, and then we're still going to go from here in a counterclockwise direction, positive 60 degrees. So positive 60 degrees would take us down here to 4 pi thirds. So this would be point B. All right. Next, we have the point 430. So we're going to go out from the pole, positive 1, 2, 3, 4, and around 30 degrees, which is pi 6. So we're going to name this point C. All right, then we have for negative 330, so out positive 1, 2, 3, 4. Around negative 330 means we're going clockwise 330 degrees, which actually takes us right back to point C. So these are the same. Then this point says we're going out negative 4, so we're going to the left 1, 2, 3, 4, and around 210 degrees, so around to the axis, that's 180, plus 30 more is 210. So again, that takes us right back to that same point. And then they want us to graph negative 4, negative 150, so out to the left, 1, 2, 3, 4 from the pole, and negative 150 means we're going clockwise again 150 degrees, which is going to take us again to point C. So it turns out that all of these graph the exact same point. This one is a positive radius with a positive angle. This one is a positive radius with a negative angle, a negative radius with a positive angle, or a negative radius with a negative angle. And it turns out that all points could be plotted in the same way. They could all have 4 different names and be the same point. So that leads us to our next question. We're going to plot this point. I'll call it point D. It's at 5, so out 1, 2, 3, 4, 5 from the pole, and negative 45 degrees. So we're going this direction. 45 degrees would be on the fourths. So here's point D. All right. Now they want us to name that point in 3 other ways. Well, this is our positive, negative. Okay, so let's do positive, positive. So point D could be out 5, so out 5, but if I go a positive angle, that means I got to spin all the way around this way back to here. So in radians, of course, that would be 7 pi fourths. In degrees, that's going to be 45 degrees away from 360, or 315 degrees. That would be our positive, positive. We've already got our positive, negative, so now let's do a negative. So we're going to go -5, so out to the left of the pole. And then we can do our positive, which is going to take us this direction. So we want to go 90 degrees plus 45 degrees. So 90 and 45 is going to be 135 degrees. So that's our negative, positive. Or we could go out to the left -5, and then we want to go a negative angle around this way. So negative 180 plus 45 more would be negative 225 degrees. So every point on the polar axis can be named 4 different ways. The form that we are going to use most is going to be the positive, positive form. So on our next page, or on the back of this set of notes, we're going to be talking about how to convert from rectangular normal coordinates to polar coordinates, and polars to rectangulars. When we convert into polar coordinate measure, I'm going to want the positive, positive version of our point. Okay, so on this portion, they want us to convert the following points from rectangular form to polar form. So this is a normal coordinate, xy coordinate. And so I'm going to go ahead and put that on the coordinate plane so we can kind of see what we're talking about. So we know x is -5, we're going out -5 this way. Y is +12, so we're going up 12 this way. Puts our point out here, so this is our point. Now if I do what we have been doing in the last few units about drawing to the x-axis and getting our right triangle, then what we know here is that this side is -5, this side is our y value 12. And so we could use a little bit of our right triangle trig to figure out what this angle is. Because remember, for a polar coordinate, we're going to need a polar coordinate is r and theta. My pen is running out of ink. It wasn't very dark anyway, so let me just switch here. All right, our polar coordinate is r theta. So in order to name this point in this form, we need to figure out what is the radius, how far out do I need to go, and then how far do I need to spin around to get there. Well, how far out I need to go on this axis is determined by how far out I am from the pole, which is really just going to be the hypotenuse. So since this is a right triangle, I can always find this portion, the r value, I guess I should call it r, not x, the r value, using Pythagorean theorem. R squared is going to equal these other two side squares, -5 squared plus 12 squared. So we have 25 plus 144 is 169, so R is 13. So the radius of my triangle, or the hypotenuse of my triangle, or the radius of this circle that I am going to spin around is going to be 13. So that's going to be the R value. For the theta, I need to figure out what the angle inside this triangle is. And in order to find that, I could use my right triangle trig. In reference to this angle, this would be the opposite. This is the adjacent. Opposite and adjacent would be tangent. So tangent of theta would equal 12 over -5. So I'm going to do second tan of -12 over 5. and I'm going to get theta is 67 degrees. Now 67 degrees is inside my triangle, and remember what I said about we're going to try to use the positive form, which means I need to figure out what this angle is, so that I'm going out to the right 13 and spinning around in a positive direction until I get to my point. So this one would be 180 minus 67, or 113 degrees. So the polar form is going to be r 13 and theta 113. So this is my polar form. All right. So really every single time it's going to be about the same. We're going to plot our rectangular point. We can find r using Pythagorean theorem. We can find this angle using right triangle trig and tangent. All right, so let's take a look at the next one. So in this one, x is 1, y is -1, the point in quadrant 4. There's our x and our y values, and you may recognize these numbers. 1 square root of 2 is going to be the hypotenuse. Now you could always use Pythagorean theorem to find it, so let's go ahead and, just in case you didn't notice that, it would be r squared equals 1 squared plus -1 squared. So r squared equals 1 plus 1, which is going to be 2. So r is the square root of 2. So Pythagorean theorem will still get you that r value. And then, in order to find this angle, we would do opposite over adjacent, or tangent of theta equals -1 over 1. And so if we do arctan of -1 over 1, we get that theta is 45 degrees. Now again, you may have recognized that 1 square root of 2 is 45 degrees. Now if we want to be able to do this for quadrant 4, we know that our radius is out square root of 2, so our polar coordinate is going to be square root of 2, and then our angle is going to have to be, we're spinning out all the way around to here, so 360 minus 45. So we have 315 degrees. Now this second one here would be a good example of us. If we wanted to do this angle here in radians instead of degrees, remember that 45 degrees is pi fourths. So if we were here, this would be 1, 2, 3, 4, 5, 6, 7 pi fourths. So we could write this as square root of 2, 7 pi fourths in radian measure. So it should specify whether they want radians or degrees, but the only ones that we're going to be easily able to convert are the ones that are on the unit circle. 113, for example, we'd have to do 113 times pi over 180 and convert it. But the ones that are on the unit circle, those are pretty easy to convert. All right. So that's going from rectangular, regular coordinates to polar coordinates. In this last section, we're going to talk about how to convert from polar to rectangular. So before we get started on this, I just want to remind you about the ratios for sine and cosine. Remember the cosine ratio is x over r. And the sine ratio is y over r. So if I'm trying to convert from polar to rectangular, if I were to multiply by r, I would get x equals r cosine of theta. If I multiply this one by r, I get that y equals r sine of theta. So these end up being the equations that I would use to make my conversion. X is going to equal r cosine of my angle, and y is going to equal r sine of my angle. So here's my x coordinate. X is r, which is -8, cosine of 60 degrees. So we need to work that out. Remember our ratios for 60 degrees. 1, 2, square root of 3. So x is going to equal -8. The cosine is x over r, so 1 over 2. So we get x is -4. For our y value, we're going to get r -8 sine of 60 degrees. The sine of 60 degrees is y over r, or square root of 3 over 2, so -8 times square root of 3 over 2. So I get -8 square root of 3 over 2, which reduces to -4 square root of 3. So this is my x, this is my y. So the rectangular form of that coordinate is going to be -4 square root of 3. All right, so these are going to be important right here to make your conversions from polar to rectangular form. Oh, sorry, let's see that. All right, so we're going to do one more of those, and then I'll let you work on your homework. So here we go. Our x value is going to be 2 cosine of pi halves. Our y value is going to be 2 sine of pi halves. Now remember, pi halves is up here at the top, 90 degrees. So x is 0, y is 1, r is 1. So we have 2, and the cosine is x over r, so cosine of pi halves would be 0. So we just get 0, x is 0. For y, we have 2 sine of pi halves is 1 over 1, or 2 times 1, so y is 2. So I have x and y, so my rectangular form is going to be 0, 2. So pretty easy to do. These are going to be our equations to use to convert from polar to rectangular. And whenever they're asking us to do rectangular to polar, we're going to use Pythagorean theorem to find r and tangent to find our angle. But don't forget that we're looking for the positive form. So although we could use 67 degrees if we went out -2, -67, we want to use the positive form. So figure out what the positive angle would be to get us to that point.